would think of how like spread it and then like this. Yeah, and I was like, yeah,
Yeah, you like that? I've never done that one before. Look at it, flip it. You may do that.
my brother, because I think I was solid too. I'm like, yeah. And I was like, so far away. I guess. Yeah.
I don't know why I wore ties. I used to wear ties all the time and I got lazy. Well, let me get the. That's not. They're not both negative. That's the problem. Oh, you actually it is negative on this one, but not that one. Okay. You know what I mean? You had those written in the reverse order that I did, but still you're missing that negative. These are the ones I had. I don't know. So, on these sequences, the big mistake was the first one. The antiderivative, after you find A and B, so you found A was 3 and B was 5. Well, I should say the number that goes over x minus 1 was 3, and the number that goes over 2 minus x was 5. Depending on how you set that up, A and B would be flipped, right? But the biggest mistake on number 1 is the antiderivative of the second term should be negative 5 natural log of 2 minus x. Right? That negative there, that's a key thing, and probably, I don't know, a handful of people missed it overall, probably 6. Yeah.
So just making like sure. So whenever x is negative, and when you're doing the root of like it, there's always a negative out in front of the natural log.
Yes, but like I don't want you to memorize that like as a rule. Why? Why is that? It just doesn't happen. Like it's not just black magic. Like why does it happen? Like what causes when you do this? I think it was 5 over 2 minus x, right? Why is the answer to this negative 5 natural log of 2 minus x? It's not just because it is, like because I told you. Like why is that negative there? Because what happened there was you did a little u sub. Not 5, though. U is 2 minus x, then du is negative 1 dx. Okay? So that's that. Next one, you get a positive 1/6 and a negative 1/6. The negative is over x plus 3. And then the last one, I just, all I wanted to do was make sure that you knew how to evaluate that. I wasn't looking for you to simplify it. It does simplify quite nicely. But yeah.
On the second one, I had negative 1/6 natural log x plus 3 plus 1/6.
And I got it wrong?
Yeah, you know.
Yeah, that's because you had it in a different order than when I wrote it. So every now and then I would just do that. So I'll fix it. Yeah. Is that gonna fix that? Power school. So, I don't know if you saw, but I put some review problems online for your test on Monday. And also I put with that, like the worked out solutions. Those are from an old, like the book that we used to use before Wright State took over. And just do the circled ones. I don't know if that was to apply. Does that apply?
What's the rest of them?
Like if you look at that PDF, there's certain ones that are circled. Focus on those first. I mean, theoretically, you should be able to do most of the ones that are in there. But just focus on the circled ones. That's a nice sample. And if you get done with those, and you want to do the rest of them. Go for it. Do we have questions about anything? Problems? That we want to work out? Yeah.
I keep getting the wrong thing on type 1.
You keep getting the wrong one on type 1?
Yeah, I also just divergent and then also convergent.
Okay, so give me a specific example. So my guess, I mean, I need to know, we got to figure out where you're making a mistake.
Well, I don't know if it's just me not looking the graph as well as a function.
I didn't hear what you said.
I don't know if it's like, I don't know the graph of the function, like to look at or.
Well, are you working these out all the way? I mean, if you're working them out all the way, you don't really need the graph. Like, so you don't really need to look at the graph. Like, you just work it out. I mean, what's the problem? Give me the integral.
It was from 1 to infinity with x times e to the negative x.
Okay, so this is the type 1, right? Yeah. And incidentally, I think we probably need to point this out with this problem. It's not going to come out till later where we're going to need to see this. In fact, when it's written like this, it's easier to actually find the antiderivative. But x times e to the negative x is the same thing as this, folks. Right? So this is approaching 0 as x goes to infinity. So it's doing what it's supposed to do. So we can actually do this. All right? So we'll change this to the limit as b goes to infinity, right? So did you do that, Maddie?
Yeah.
Okay, so then did you find the antiderivative? Did you integrate by parts?
Yeah.
So did you get the antiderivative as this? Hold on, x e to the negative x minus e to the negative x?
Yeah.
Okay. Did you do the shortcut or did you actually work out UV and all that stuff? Just curious. Like Rapido.
No, I didn't.
You didn't do Rapido? Oh, okay. So that's the antiderivative, right? So we'll evaluate him from 1 to b, and we're going to do the limit as b goes to infinity. Here's where it's going to be helpful to think about x e to the negative x like this. So we'll do limit as b goes to infinity of b over e to the b minus 1 over e to the b, because that's what that is. E to the negative x is 1 over e to the x. Minus 1 over e to the 1 minus 1 over e. Okay? I feel like I'm missing a negative somewhere. Am I?
Is there a negative on the outside of this? It's negative b over e to the.
Right here? Let's go back and look at the antiderivative. Let's compute that real fast. Just compute. I was doing that in my head and I might have. So it's u times v negative x e to the negative x minus the integral of v du. So I did have that wrong, didn't I? Did you get this as your antiderivative?
I have negative.
Yeah. Did you have negative and then plus?
No, I still have a negative. That's
Because
because it would be net plus one negative.
Oh, I didn't integrate this. Thank you. You're right. There we go. So they're both negative. Beautiful. All right. So let's fix that right here. So that's going to make that negative there. That's negative there. That's negative there. And that's good. Okay? Now, we're ready to take the limit. As b goes to infinity, what's this doing? Well, it's infinity over infinity, right? So technically, this is a L'Hopital's rule problem. Now, you may know what L'Hopital's rule is going to tell you because you probably already understand that this exponential is going to dominate this b. So this is going to go to infinity bigger than the numerator, faster than the numerator. So this is really going to go to 0. But we'll go ahead and do L'Hopital's rule to prove it in a second. What about this term right here as b goes to infinity? What's this equation? 0. So I'm going to go ahead and make that go to 0. Okay? These guys over here, they're just hanging out. They're just constants, right? So this is infinity over infinity, so we'll load this. So take the derivative of the top, -1. Take the derivative of the bottom, e to the b. And we'll go ahead and simplify this. That's -2 over e right there, right? So now we're here. As b goes to infinity, what's going to happen to this? This goes to 0. Minus -2 over e, so that'll be plus 2 over e. So what does this integral do? Converges. Okay, so you see how L'Hopital's rule came into effect there? Now what did you do wrong?
How does negative 1 over 0 and
How does -1 over e to the b? Why is this right here equal to 0? That's what you're asking me, right? Well, e to the b is getting huge. So this is like big time bottom heavy. Right? 1 over infinity is going to 0. Right? Do we have those in our hip pocket? We should have those in our hip pocket, guys. Like, we should know, and not from this class, you should know this from previous classes. Something over infinity, like, that's going to 0. Right? Something over 0 is going to infinity. We should know that.
I know that, but I don't know like the e to infinity or like.
You don't know that e to the infinity is going to infinity? We should know that too.
Yeah.
Yeah.
I also like the natural log of infinity. I wouldn't know that.
Well, natural log of infinity, I might be more able to give a pass on that one because you probably don't have a lot of experience like working with the graph of natural log of x. But if you know what the graph of natural log of x looks like, then you should know what the natural log of infinity is. What's the graph of natural log of x look like? It looks like that. Right? So what happens as x gets huge on that graph? It goes to infinity. Very slowly, right? That graph is not increasing very fast. Why is that graph not increasing very fast? The derivative of that graph is 1 over x. Right? In fact, the rate that it's increasing is decreasing because it's concave down. I mean, the derivative of natural log is 1 over x, right? So, I mean, how fast it's changing here is faster than how fast it's changing there. Because 1 over x is smaller for the bigger values of x. Make sense? But yeah, it's real easy to get those jumbled in your mind. You know, like 1 over infinity, 1 over 0, 1 over infinity, you know, it's easy to get confused. I get it. Yeah, no.
So if it's increasing by 1 over x and it's going to infinity, doesn't that basically mean it's not increasing? It's just like 1 over infinity equals 0.
I think you're combining all those ideas into one. The rate that natural log of x is increasing, the rate of change, okay, of natural log of x is 1 over x, right? That's the rate of change. You are correct that 1 over x, as x approaches infinity, is 0. What does that mean in the context of that natural log graph? The fact that 1 over x, as x goes to infinity, is approaching 0. Or, in other words, the fact that the derivative of natural log of x is approaching 0. The slope of natural log of x is approaching 0. But natural log of x still forever increases. Right? Does that make sense? But the slope is approaching 0. The derivative of natural log of x is always positive for positive values of x, right? So the derivative of natural log of x is always positive. So that means natural log is always increasing. So could we have figured out what the natural log of infinity was without really knowing about that graph? Yeah, if you actually think about the derivative of natural log. If you take the derivative of natural log and you get 1 over x, you could make that argument like, oh, well, 1 over x, that's always positive for positive values of x. Right? It means natural log is always increasing. Which means it's getting bigger. It's not very fast. Okay? mean, natural log is like a wood. I mean, it's slow. Like, it's not increased very fast. It's like JV in terms of speed. Other questions? Integrating by parts, yeah. Remember how to do that? Anything like that. As long as it's a positive, like number bigger than 1. That's it. So what's e to the negative x do as x goes to infinity? Or 0. Because e to the negative x is the same as 1 over e to the x. Right? It's like March killed you guys. I get it. You got another one? Talk to me.
Can you do the interval of e to the negative x times the cosine of x from 0 to infinity?
Ooh, that integrate by parts again. From 0 to infinity. E to the negative x cosine of x? Okay. So we're first going to integrate this by parts. Let's go ahead and do that first. Find the antiderivative. So we're going to do u is e to the negative x, dv is cosine of x, du is negative e to the negative x, and v is what? Sine. Okay? Now, if you've done enough integration by parts problems, you probably would recognize that this is the one or the kind of problem where the original pops up. Okay? So let's go ahead and work it through. So it's going to be u times v minus the integral of v du. And since that's minus minus, I'll make that a plus. And now I've got to integrate by parts again. So I'm going to put my little bracket here. I'm going to say u is e to the negative x, and dv is sine of x. Oh, I lost my negative here. Can we remember that? That should be negative right there. I lost that.
I don't think so.
No,
Because it's not
you, not you.
It's not d.
Oh, you're right. I'm sorry. I was here and I thought back to that. Yeah, you're right. Sorry. So what's the antiderivative of sine? Negative cosine. Right? So I have u times v minus the integral of v du. So this is minus, that's going to be plus. And so now the antiderivative here, I'm going to go ahead and set it up with the equation. So that's this one minus this one minus the original. So now what happens when I bring this to the other side? I get 2 of those. So finally, the integral or the antiderivative of e to the negative x cosine of x is 1/2 e to the negative x sine of x minus e to the negative x cosine of x. Right? So now we'll go ahead and do the improper thing. I knew that antiderivative was going to take some time to work out, so I just worked that out ahead of time. So now the improper thing says, what's the limit as b goes to infinity of 1/2 e to the negative x sine of x minus e to the negative x cosine of x. And we got to evaluate that from 0 to b, right? And at this point, I think it would be very smart to get rid of that negative or e to the negative x and write it as a fraction. Okay? So here we go. 1/2, that's going to be the sine of b, sib. How about sine of b over e to the b minus cosine of b over e to the b, right? Minus 1/2 e to the 0 sine of 0 minus e to the 0 cosine of 0. Okay, so is everybody cool where we are right now? And evaluating that integral, I mean, that's a lot of stuff you got to write down. A lot of things to keep track of. Right? Okay, so are you ready to do the limit thing now? As b goes to infinity, what's going to happen to this term right here? It's going to go to 0. I mean, sine of b basically is just flopping back around between -1 and 1. This is just beating the crap out of that. So this is going to 0. What about that? That's also going to 0. So, oh, wow, both of these babies go away. Okay, so now we're just left with this. Okay? E to the 0 times sine of 0. What's the sine of 0? 0. Times e to the 0, which is 1. So 0 times 1, that's 0. E to the 0 times cosine of 0. That's 1. So this is -1/2 times -1, or 1/2. So what does this do? Convert it. Right? It turns out, my friends, I'm just giving you a little extra information just for free. How many of you are in stats right now? No one? No one in here is in stats? Anybody taken stats already? You took stats already? Okay, so you're the only one that might make sense out of that. This ended up being 1/2, right? And we are only going from 0 to infinity. If you integrate that from negative infinity to infinity, you get 1. E to the negative x times cosine of x is what you call a probability density function, because the area under that whole curve is equal to 1. And when you take stats, you're going to learn about like the normal distribution, the normal curve, all these different probability curves, that when you find areas underneath them, you're getting probability values. So e to the negative x cosine of x is actually what we call a probability density function or probability distribution function. But that's how you take that, like I'm talking in foreign language. Does that make sense? I mean, is that ringing a bell what I'm saying? I don't think I've ever had a class in Calc where no one was in stats at the same time. What? Stats really isn't that hard. I would say this is harder than stats. Stats is hard this year because Brewer's not here. That's just really making it hard. So, Coleman is his name. He's subbed before. I don't know if you guys have ever had him for anything. He's been a long-term sub in math, so his classes. What did you have him for? Oh yeah, he subbed for when Adams was gone for a little stint a couple years ago. He subbed for him. In fact, that might have been his first like big gig. Other questions? So if I gave you this improper integral right here, how many of you can look at that and within 5 seconds tell me if that converges or diverges? Oh, can you not read that, Ross?
Yeah, I can.
It does look kind of blurry, doesn't it? Like when I'm standing over there, I'm like, oh, you really can. How about if I write it like this? Can you see it now?
No.
What the How many of you can tell me was that conversion or divergence in less than 5 seconds? If you can't, you didn't watch the video yesterday. What does that one do? What? Converges. That's a p integral with p equal what? 5 halves. That's greater than 1. Okay? So if you learn that p integral rule and you get a p integral, if I give you that, if I give you a p integral and you know that rule, use it. Don't work it out. Use the rule. No, not in that case. If I just ask you straight up, does this converge or diverge? You don't have to give me the number. Yeah, that's a good question. Other questions? Anything else? What time do we get out? Coming up. So I'll answer questions on those review problems if you have questions about those tomorrow. The way your test will be structured is I got to look at how much. I got to modify the length of it based off of 40 minutes. But it'll be like, maybe there'll be 10 problems and you have to do 9. If you get, but if you do all 10, it'll be good. So the way I'll work it is let's just make 10 because that's an easy number. So I'll grade all 10, but it would only be out of 9. So if you do all 10, you'll get points. Assuming you do something correct on all 10 of them. The only stipulation on that might be is if I stick an improper integral on there, like that, I'll force you to do that one. So it might be like of these first 10, do 9, and then of these other 2, do both. Do 1 or do both of them. Like I might force you to do the improper one. Well, I guess it technically really wouldn't still be forcing you because they were all equally weighted. You still choose to not do the improper one. But So that's that. Are we excited for this test?
You made it sound so simple.
It is hard. It's going to be hard. Like, I'm telling you, if you don't prepare for this test, your grade is going to really, really hurt. Yeah.
What do you think it'll be like compared to the quiz?
I think it'll probably be a little harder than the quizzes. Like, not all the quizzes. Like, yesterday's quiz was super easy. But, like, if I'm going to test you on partial fractions, it can't get much harder than yesterday's quiz. Right? I mean, well, the partial fraction question. Because, I mean, with the shortcut, like, how difficult. All I can do is make it so that that negative comes out, right? I mean, like, yeah.
Don't do that.
And I wouldn't be surprised if I do it again, because that negative is really important when we solve the logistic differential equation, which we'll be doing here soon. Just out of curiosity, did you guys study logistic growth ever? Not log, like logistic. Like logistic growth is the curve that looks like this. It's like population doesn't really grow logistically. Population doesn't grow exponentially, it grows logistically. Meaning it starts off exponential and then it starts to level off. Okay? And diseases like COVID spread logistically, not exponentially. They spread fast in the beginning and then level off. In fact, the derivative of this curve right here is a curve that looks like this, which you've seen that a million times back in March. Like the whole flatten the curve thing, that's the curve they were talking about. So, yeah. See you later. Have a nice day. Oh, I got signers. Anybody else is scheduling?
I'm doing both. I'm doing AP second semester, yeah.
Okay, so I have, right now, I have everything except one, like the 10th unassigned.
Calc 3 is easier. Like if you do homework and you're a halfway decent student, what did you just say?
This class is so hard. Oh my gosh.
This class, I mean, it really is. And this class is hard right now, but this class is going to get easier. Like it's just hard right now because this is hard. This is the hardest thing we do all year. Honestly, I'm not kidding.
This is hard.
No, what? It's just, they're going to be, I mean, it's like the tests are 80% or something. So, like, I'm not sure. I think we'll be able to squeeze in the second test before the end of the quarter because the quarter actually doesn't end until after spring break. Yeah, so that you'll have two tests for this quarter. Like this, the next test that we have after this is probably one of the easiest tests of the whole year. Like because it's.
You're welcome.
I mean, kids just find volume. Like volume. I think all three of you would be just fine in doing both.
I think Aaron might be there. Yeah, that's what it does. We have so many freshmen coming to the listings, like every freshman. There's like 30 of them. Oh, yeah, because it's Nelly and then, yeah. Yeah, and then Julia Slaughter.
Well, that too, but like, I don't think,
You didn't get anyone
I
to
think
do
we're underestimating how bad, like, it truly was.
I don't know because I haven't really seen like I know Julia's sister is pretty good, but she is super small. Like she needs to live. Yeah, but I think she's like yeah, I think Julia like said like she's kind of better.
You don't have to
Just a
agree
little
with
wrong,
me,
but I
right?
get to push off the ball. Yeah, from what I've
The
seen her
letter
play,
grade? Yeah.
I think she's
But it's the point difference is like
smarter.
that
Yeah,
one.
like yeah, she doesn't. Yeah, yeah. That's the thing. And she actually, passes the ball. I bet she is.
Now?
Julia said it too, so, yeah, and we said it.
Oh, yes. Oh, yes. We like that. We like
I think
that. We like it.
It's like a few.
Literally,
Yeah, I think it's like Mary and, oh, yeah, like Megan maybe will be pulled up for our seat.
We better have a good day.
For the whole thing.
Yeah.
Yeah, how many questions are there this year? Like, I know, I feel like I never really talked to them. No, they're really scared of us. Yeah, there were really scared of us. They were. There weren't very many of them. It was like Cora and our girlfriend. And there was like 6 maybe? Audrey. Yes, Audrey. She even like walked this way. Yeah. So she'll be. And this. Look at this class is talking to you. So, yeah, I don't really need password well, I mean, I already got it. So. No reason why I didn't get it. So I have to come after I have to come to school, just for one class. Yeah, let's try one, but I'm taking it at juniors. I don't have to do that. Look at she wants to, oh, you yeah. I don't know something. Yeah, I do, but, yeah. I'm gonna take them in college anyway, so. I guess I should take a different class.
Okay.
He doesn't do it. Yeah.
Hey, guys.
Hello.
Hey, Aaron. Nicole. Denise? Oh, wait, Gavin, you got that bonus. What? I got the bonus question? I'm trying to figure out how to do that. I don't get them. There, I can't do anything.
Huh?
Gubby, I can do that.
Oh,
Okay, then. Hey, Lex. Bye-bye. Yes. Hey, Lex. I got all kinds of stuff here. Bye-bye. I got all kinds of stuff here. These are all papers that you work here for. So hey, this was pretty cut and dry. Like, I mean, most people did fine on that thing. The biggest issue was the negative on the first one. Why that negative should be there on that first one. A lot of folks forgot that negative. So if you've noticed, I put some problems online for review for the test. Those came out of an old book. And then I also put the solutions, worked out solutions for those. Now there's like 145 problems here, but I circled some of them. Like, I focus on the circled ones first, and then if you get those, then maybe you can go back and do the other ones. Focus on the circled ones first. And then, like, let's talk about the test just for a second, so you can, while it's on my mind, you can think about it. The format of the test will be, like, maybe there's 10 problems on it, and I'll say, do 9. Pick 9 of these 10. And then if you do all of them, you can get extra. Okay? Does that make sense?
So if you did 9 correctly and 1 incorrectly, what would the end?
You would get 100%. But more than likely, if you did 9 correctly and you did 1 incorrectly, but you did some stuff right on that 1, you're probably going to get over on it. I really should. It just makes it more difficult to grade. I should do it so that you have to do the 10th one perfect to get the extra. But it's so much harder to grade that way. It's easier just to grade all 10 of them and make it out of 9. So.
Is that an extra number of like columns like around 10?
I've got to think through. I have to think through what it's going to be for 40 minutes. I mean, probably somewhere around there. I don't know if it'll be 9, 10, 8. Because we only have 42 minutes.
Are you getting anything like going harder than anything you've ever done before?
No, they'll be comparable to ones that you've seen before. I will say that, I mean, you know, the past 2 quizzes that you've had have been pretty easy. Now, yesterday's, if you think about that, the partial fractions is easy because we didn't do the hard ones. If we just limit it to non-repeating linear factors, those are easy. Like, those should take you 2 seconds to do. You know, so but they're going to be similar to ones that you've already had. I mean, possibly the same problems. I mean, you've done so many over, you know, all over this time, you know, especially when you throw in just 20 or so reviews that I threw in there. Like, but you definitely need to prepare for this test. And if you wait till Sunday to prepare for this, you might as well just take the day off. Like, I mean, you should be preparing now. Like, work on those review problems tonight, tomorrow night, Saturday night, Sunday night, or Saturday afternoon, Sunday afternoon. Like, don't sit down on Sunday like, oh, I got a calculus test, and crack open your book for the first time in 4 days and think, oh yeah, I'm going to study for this, because you're going to get through about 3 of those review problems. Right? And you're like, I don't know how to do any of this. I'm going to fail. This is so hard. Do you have questions for me about any impropers? Yeah.
So not when working it out with the answer. For the 363, would it be different except for one? That the integrals in zero infinity of finite dx.
The 0 to infinity of sine.
Yeah. I got like, just like this plus 1.
So you're going to change this to the limit as b goes to infinity, yes?
Yes.
And so to find the antiderivative, what's the antiderivative of sine? Cosine. Evaluate that from A to B. Negative cosine. Thank you. And then so the question is, really you're asking me what is the answer to that limit problem? That's really what you're asking, right? Because the answer to that limit problem is going to determine the answer to this problem. I mean, cosine of 0 is 1, correct? Well, what is the cosine? What happens to the cosine as b goes to infinity? Okay, it's just oscillating back and forth, right? So this right here does not exist. Okay? So this is d and e, which doesn't matter what this is. So it means this cycle.
So that's what I knew that for D and E. I just didn't know if since it was plus 1, if we did any of that.
No. Yeah. Once you get d and e or infinity, the game's over.
Okay.
Yeah.
Okay. Second question about like the second part one, so type 2.
Type 2s, yeah.
Yeah. So, okay, so when the vertical asymptote or the asymptote is one of the numbers that you're solving for.
In one of the bounds?
Yeah.
Still do it the same way.
Same one.
In fact, if you do it if the vertical asymptote is one of the bounds, you really don't even need to break it up into 2. Yeah. And what often happens when you do break it up into 2, whatever the one does, the other one does. So it's like you almost don't even really ever need to break it up into 2 because they both do the same thing. And once you get infinity, you're done. Right, on either side of the asymptote. Like, when you think about a vertical asymptote, okay, just like that graph right there, right? Say we're integrating this from here to here, right? Well, whatever this thing does on the left side of the asymptote, whether it converges, if there's finite area there, it's going to be the same thing on that side. They're typically symmetric like that, right? Now, if the bounds aren't symmetric about the asymptote, then you might get a different numerical answer. But if I'm just asking you whether it converges or diverges, I don't necessarily care what the numerical answer is. You follow what I'm saying there, Daniel? Yeah.
I'm thinking they probably wouldn't have anything numerical necessarily, but
they would only have the same numerical value if the bounds were symmetric about the asymptote.
Yeah.
And the graph, the function was symmetric about the asymptote. Well, this is going to happen when you have something. This shape right here is going to happen when the denominator is x minus c squared, or to an even power.
No, I'm saying like if you have one that converts and one that converges.
Oh yeah.
Right.
Sure. Other questions? Now I did work out, you guys haven't asked them, but I did work out some of the problems in the last period. I'm happy to work with that for you now, or you can, yeah.
Can you do 356?
356.
Yeah. You go from 1 to infinity, 1 over x, and that's all of x to x.
So,
No, not all of x is
that makes it even easier. like that. Oh, nice. Okay. So we don't find the antiderivative here, right? That's what we got to do. So what I'm going to go ahead and do is just go ahead and find the antiderivative before I change everything to b's and do the limit thing, because it'll just be cleaner, I think. Because the antiderivative involves some work. It's not one that I just know. Okay? So how do you find the antiderivative here? That should be a... Maybe. It's a lot easier though another way. Mia, maybe this will make it pop. U sub, right?
Yeah.
So u is natural log of x. du is 1 over x dx. So that's u du. That's u squared over 2. Yeah. So that's natural log of x squared over 2. And now I'm going to evaluate this from 1 to b, and then I'll limitize it. See how I did that? Instead of changing the limit at the beginning. Sometimes when the antiderivative is a little bit more complex, that's how we like to do it. I'm going to put those lights back in. I think that will make it more easier to see. You guys agree with that?
Maybe not like first one, but
Like this with these two here?
yeah, and
And then that one there? Okay. I'm going to go find a ladder. All right, here we go. So, now my friends in third period, you know, they're struggling a little bit because they said, like, I don't know what natural law is. Like, they're looking at that limit and they're not sure what the answer to that limit is. What happens to natural log of b as b goes to infinity? It goes to infinity. Okay? Now, you can memorize that, certainly, but it's more important to me that you understand why it goes to infinity. Like, why does natural law go to infinity? Well, if you want the graphical explanation of that, the graph of natural log looks like that. Okay? It actually is not flat. Okay? It doesn't have a horizontal asymptote. It just keeps getting bigger and bigger and bigger. Why does it continue to increase? Because the derivative of natural log of x is 1 over x. And that's always positive for positive values of x. So if the derivative is always positive, the function is always increasing. So that limit is going to be infinity. Right? Now, it is true that the derivative of natural log of x does approach 0. The derivative of natural log of x does approach 0. What does that mean if the derivative is approaching 0? What does it mean if the derivative is approaching 0? What does it mean about that graph? It explains something about that graph.
Just like the slope is getting increasing and increasing.
The slope is getting smaller, which means this graph is getting flatter, right? This graph is flattening out, but it's still increasing. Okay? It never gets flat. Okay? So what is this answer here? Well, natural log of 1 is 0. And we already said natural log of b is going to infinity, so this limit is infinity, so this baby is a diverger. Oh, I'm offended by something I wrote. I'm offended by something I wrote. Anybody know what I'm offended by? I don't. This doesn't equal divergence. Like that.
So should you write that arrow symbol whenever it diverges, or
Right, what?
What should you write between the equation and divergence? Should you
Just write the word diverges, but just don't. I don't like saying equals diverges. I mean, if you did it, I'm not going to take points off. It's just. I mean, that's bad grammar. It's bad grammar in mathematics. It's just not. You can't equal diverging. You can be diverging. You can be divergent. But you can't equal. I mean, equal is quantities that are the same. Diverging is not a quantity. You know what I mean? What other questions? What other questions do you have? Yeah.
So like, in this case, if you put that the limit of ln x, or rather the integral from 1 to infinity of ln x over x dx is infinity, is that a correct answer, or do you want us to put converges or diverges?
Technically, the answer would be it diverges. Yeah. I mean, now I think people will people will accept infinity as the answer to it. And I probably would. I think part of that is going to be might depend on how the question is asked. If I just gave you this problem like this, and I said, what's the answer to that? And you said infinity, that would probably be much more acceptable than if I said, does this integral converge or diverge? And you said infinity. You know what I mean?
Yeah.
Like you see the distinction? It's a different question. Lay it on me.
Okay. So the integral from negative infinity to infinity of e dx over 1 plus e dx. Yeah.
I'm always fascinated how you guys ask totally different questions than third period. I mean, I'm not bothered. It's just very interesting.
I wonder, part of it maybe like if you want to like something more with some of those answers, and or the way you framed it during that class.
I don't know. What was the bottom? 1 plus e to the x?
E to the 2x.
Oh. Maybe. You gotta find that anti-terrific, don't you? Maybe this will help. Is this true, Leah? That's true? That's true? So if I do a U sub here, I end up with this. Yes? And what's the antiderivative of 1 over 1 plus u squared? Man, it'd be helpful if you knew this, if it just had, if this was in your hip pocket and you didn't have to do the trig sub. It should be du, Gavin. Very good. What is that antiderivative? Alex, you know?
I forget the exact word, but it's like tangent to the negative first of u. Am I right in that?
You are right in that, but I'm offended that you said it. I mean,
I couldn't remember the word.
this is varsity here. Inverse tangent. Now, unless you're Samuel, who insists on saying arctangent, which I love.
When you write out tangent, because like some people think that.
Yeah, I'm not dissing you. I just love the fact that that's how you always call it. Inverse tangent of u, yeah. So now go back and resub inverse tangent of e to the x, which I have no idea what you, okay, fine. And now we'll do the limit. Oh, wait. So that's our antiderivative, right? So technically speaking, we need to probably break this up into two chunks. Okay? So how about we say that we go back and do this from negative infinity to 0 of e to the x over 1 plus e to the 2x, plus the integral from 0 to infinity of e to the x over 1 plus e to the 2x. And now we'll do the whole limitizing thing. So this first one will be the limit as b goes to negative infinity of b to 0 of e to the x over 1 plus e to the 2x. And then this one will be the limit as b goes to positive infinity of 0 to b e to the x over 1 plus e to the 2x. Now I already found the antiderivative, so I'm just going to jump down here and do it. So the limit as b goes to negative infinity of the inverse tangent of 0 minus the inverse tangent of, sorry, not 0, e to the 0, e to the e, plus the limit as b goes to positive infinity of inverse tangent of e to the b minus inverse tangent of e to the 0. Yeah.
Like this problem. But is there a standard variation for units when you do multiple in the same problem?
A lot of times we'll do you throw a W in
That's why you do it.
there. But there's no industry standard.
And then I know like a lot like.
In fact, this book right here, this is like my favorite probably my favorite calculus book ever written. They don't even call them U substitution. They use W for everything.
Every single factor is
yeah.
It's really easy thing.
Okay, so I've got this now. The limit as v goes to infinity of what we got going on here. Inverse tangent of what's this? E to the 0. 1. So it's inverse tangent of 1 minus inverse tangent of e to the b. Right? And this is b goes to negative infinity. Plus the limit goes to positive infinity of the inverse tangent of b minus the inverse tangent of 1 again.
Why is it not B?
Oh! It actually won't matter. Okay. is the inverse tangent of 1? Pi over 4. Minus, you want to be careful here, my friends. What is the inverse tangent of e to the b as b goes to negative infinity? Okay, hold the phone here. That's like saying this, kids. As b goes to negative infinity, that's like 1 over e to the b. Right? What's happening to e to the b as b goes to negative infinity? What happens to just inside there? What does that go to? As b goes to negative infinity, what happens to e to the b? What's it approaching? 0. So this is like the same thing as the inverse tangent of 0, which is 0. Whoa, Hall. Plus the inverse tangent of e to the b as b goes to positive infinity. That's like as b goes to positive infinity, e to the b is going to infinity. So that's like the inverse tangent of infinity, which we actually determined which that was the other day. That's pi over 2. So this one's pi over 2. And inverse tangent of 1, we already said was pi over 4. Yeah? So those pi over 4s cancel out, and we're just left with pi over 2, so this is the convergence. Right?
So couldn't it, the arctangent of e to the b inverse infinity also be negative pi over 2? Or like 3 pi over 2?
No, because the inverse tangent at 3 pi over 2, tangent's negative.
Oh, yeah.
So it could be, theoretically, it could be pi over 2 or negative 3 pi over 2.
Okay.
But anytime you give me an inverse tangent value, your answer has to be between negative pi over 2 and pi over 2. Otherwise, inverse tangent is not. It's a nice eraser. Yeah. When I was a grader for the AP calculus test, they gave everybody 2 of those erasers. Every grader got 2 of those erasers.
We have all application forms. They're nice applications you get from by law.
They're like those are like that's the best eraser that's made. I'm not kidding. And in fact, when the reading was over, I went around to all the tables and took the extra erasers that people want. So I still got a couple left. Other questions? Now, if you're curious, the one of the ones that on the homework that required, there were a couple that required you to integrate by parts. I worked those out last period. Maybe you want to take a look at those, watch that video. If you had trouble with that, like one of them was like x e to the negative x. The other one was like x cosine of x. Okay. That's good stuff, man. Improper integrals. So I'm just curious. How many of you right now, if I gave you that problem, could answer that problem in less than 5 seconds, could tell me if it converges or diverges? Without doing any work at all. You can look at that and tell me if it converges or diverges. Because if you can't, you didn't watch the video yesterday. Nicole, what does it do? No idea. Did you guys hear anything? You just said, did anyone come out of your mouth?
Yeah.
So what's this one? 3/2 is not less than 1, sweetheart. 3/2 is bigger than 1. So that one does what? It converges. It's a p integral. 1 over x to the p. So if I give you a p integral on the test, and I ask you if it converges or diverges, you can just tell me the answer and just say that's p integral with p equals 3/2 converges. No work.
So if you ask for like the value of it and it was
Right. If I ask you for the value of it, then I would be specific. If I'm just going to ask you if it converges or diverges.
but if you ask the value of it and it's diverged, would you take it as the integral?
Yeah.
Okay.
Yeah, that goes back to like the way the question's worded. Because if I ask you for like, I just give you that integral and say, what's the answer? Well, that answer is it diverges. Or it's infinity. I love the integral.
Is there other integrals with special names or that?
Not in here, not in this class. Maybe down the road. Is anybody in here taking stats?
I'm in it right now.
You already took it? Or you're in it? You're in it?
You know, it's cool.
Yeah, one of the problems on your homework was I can't remember which one it was. It was like x e to the negative x, and I think the answer ends up coming out 1/2. And I remarked to them that if you integrate that function from negative infinity to infinity, you get 1. Because that's actually what's called a probability density function, or a probability distribution function. People in stats know what that means. You guys study? Have you not studied the normal distribution yet? The normal curve? Normal CDF?
Yeah, we use it. I don't know what it means, but.
Yeah, normal CDF. When you're doing normal CDF on your calculator, like you're finding the area under a curve. Like you're doing an interval. And you're integrating the normal distribution function. And a probability distribution function is any function whose the total area under it is 1. So.
I'll be honest, I never really connected that.
Well, I don't know that. Honestly, I'm not sure that the situation that you're in right now, you would have had the opportunity to make that work. I mean, with Brewer not there,
Yeah.
like.
Yeah, we just sit there and watch videos.
Yeah. Brewer probably would have made that connection for you. She would have said, "Oh, if you're in Calc, what time do we get out of here?"
24.
Oh, okay, 30 minutes.
Yeah, we do this sensor time, so like, it doesn't really.
Oh, yeah, it's an awful situation. Yeah, I'm not even gonna pretend that it's not. But like, you know how difficult it is to find somebody who can just walk into an AP statistics class and teach it. I don't know that there's anybody in our department that can do it.
It's okay. My counselor